Hi, everyone, and welcome to the Earth Day Everyday podcast, where we aim to spotlight exemplary activists, policymakers, and changemakers in the field of sustainability and climate change. I'm your host, Aryan Doshi, and today we are extremely lucky to be joined by Hanno. Hanno is a research scientist at Yale University studying green chemistry and green engineering. Hanno, it is absolutely wonderful to have you with us today.
Thank you. Happy to be
Yeah,
here.
Yeah, no, thank you. Thank you so much for taking the time. And maybe before we sort of get, straight into our conversation, something I always like to preface my podcast with is just can you tell us a little bit about your story, your background, and where did this interest in green chemistry come from and when did you know that this was a field that you wanted to pursue in the future?
That's just a light entry question, huh? So, I'm originally from Germany. I studied chemistry there. I then moved to your northern neighbor. I did a PhD in chemical engineering in Canada,
Wow.
McGill
Yeah.
University, and then I moved about 6 hours south to New Haven, where I am now.
Yeah.
How did I get interested in this? Well, the idea of green chemistry, and maybe I should start with that, is really to try and design materials, chemicals, processes that involve less hazardous or non-hazardous materials across the life cycle.
Yeah.
And so the idea is if we don't have things that are hazardous, a hazard can be toxicity, a hazard can be forever chemicals that don't biodegrade, a hazard can
Yeah.
be chemicals that alter the atmosphere and lead it to warm up,
Yeah.
right? So to include that into design of chemicals seemed to make sense to me, right?
Yeah.
We make chemicals and we're really good at it, right? And they perform all these functions and they all do all these things that we want.
Yeah.
But why do we have to accept that there are possibly negative consequences that come
Absolutely.
along? Can
Yeah.
we reduce those or eliminate them?
Exactly.
So that's my motivation.
Yeah, no, and I think that sort of that origin story it is so unique in that sense, right? Because a lot of people maybe they approach a certain field, but I think a lot of the times they step back, they don't step back and realize what other field can this be tied into. And I think that's one of the unique parts about environmental science, right? Is that it's interdisciplinary. So whatever field you may be pursuing, whether it be chemistry, whether it be math, right? There's always some small way you can tie it back to sustainability. So I think that's an incredible story. And maybe if we can just sort of focus first a bit of a broad question, and then I'll focus on some specific case studies. Is today when you look at how green engineering is able to impact society, are there any sort of regulatory gaps that prevent us from being able to integrate sustainable materials within society? Are there any examples where you feel we can make our fabrics more sustainable, the products that we put out in the supermarkets more sustainable? But is there some sort of regulation that's preventing us from getting to that stage?
Mm, It's a good question. It's a good question. Is it a regulation that's doing that, right? Or is even regulating this the right approach?
Yeah, exactly.
I don't know if that's the answer. I mean, you know how people react when they're being told you can't do this, you can't do that.
Absolutely. Yeah.
I don't think the way forward is to, I mean, of course you need to in certain places ban things. When
Sure.
there's
Yeah.
toxicity problems, when there's problems, you need to think about regulation. But regulation could also be how can we make it more attractive to,
Incentive.
to
Absolutely.
develop and design materials that
Yeah.
are also environmentally better? And how can we make innovation more? How can we push forward innovation as well?
Absolutely.
I,
And I know
I,
you, yeah.
sorry, I think
No,
that's
no, no.
actually
Go ahead.
regulatory strategy than trying to say, oh, you can only use this, you can only use that.
Yeah. And I think on that note, you were talking about how do we make it more attractive, more appealing to the consumer, right, to people of society. Are there any examples that you've been able to see where you're actually able to create incentive where now we see citizens, members of society wanting to engage unknowingly in some sort of a sustainable behavior? Like, have you seen that play out in the field of green engineering?
I mean, if you think, if I understand your question right, I mean, if you think, for example, about the idea of putting solar panels on your house,
Yeah, yeah,
right? And that, of course, there's several things that came together. There
absolutely.
were financial incentives by the government. Solar panels became a lot cheaper,
Yeah,
and people realized, oh, if I put this on there, I'm actually much less reliable on changes in power prices, for
sure.
example, right?
Yeah.
And so, that's one where certainly help by the government to make that change certainly helps. Just one.
Absolutely. Yeah. So, and I think there's like you say, I think solar panels is a great example, right? Where it's not only are you benefiting yourself, maybe benefiting your family, right? But you also are pursuing something that's better for the planet. And so unknowingly you're able to get into the mindset, the thought process of people in society and allow them to engage in such behaviors. And I think you were saying before that regulatory action isn't the way, and I think you're right because a lot of the times people don't want to change, right? They just want to do what it is that's easier for them.
Let me walk that back a bit. I don't. I guess if you mean regulation by banning things,
Yeah,
but
exactly.
regulation can also be right financial aid for certain things. So I think that absolutely is part of the mix. And again, as I said, right, there are certain things. I don't know. Think about arsenic. Think about lead. Think about really toxic materials. There need to be rules on where they can be and where they can't, and that's people can be exposed to it, children can be exposed to it, they can cause harm in the environment. So let me walk that back and say I think they are part of the mix,
Yeah.
um, carefully.
Yeah, but not in the context of, like you said, banning, right? Because that's probably not gonna be appealing, but a little bit of financial aid to help them out, that's always something you want to pursue. Yeah. And I think maybe if we can just focus on a few specific case studies that I know you have a lot of experience in, right? One is the pharmaceutical industry. And I think when I was reading up on it, it was a little bit of a fascinating sort of field for me because when we sort of see these medicines, when we sort of see these vitamin tablets, little do we know just the sheer amount of waste that's produced in the process, the sheer amount of energy it takes to create that minuscule tablet that we utilize on a daily basis, right? And so, what role do you think that the pharmaceutical industry should play when it's trying to reduce its carbon footprint? And I know we were just talking about legislation, but do you think legislation can have a maybe a little bit more of an impact here in terms of how we're able to actually design these medicines, these tablets in a sustainable manner? Because I think that's something that, a lot of society, their first thought, their inclination when they see these medicines isn't that we've done something that's bad for the environment. It's more of a connection to human health, right? And so can you maybe talk about that and what have you seen play out in that context in the pharmaceutical industry?
Yeah. I mean, the pharmaceutical industry is a really tough one, right? They make a lot of the important drugs that we need. So
Yeah.
it's not the first place that you think of where changes need to happen.
Absolutely, yeah.
And the other thing is, sure, we can talk about the carbon footprint, but I think the waste is another big issue, right? So many people may not know this, but the pharmaceutical industry often will take, chemical ingredients and go through several steps to come to a product. Now, in chemistry, whenever you have more steps, you will never get what we call 100% yield. So you'll never convert everything to what you wanted it to
Yeah,
be. There will
yeah,
always be some waste. And
yeah,
so if you do this over several steps, there's a lot of waste.
yeah,
And what's the character and the nature of that waste? So are you making a drug that's going to help against cancer, but you're producing waste that causes cancer?
yeah,
So that's a really tough
yeah,
question, right? So am I saying we don't need pharmaceuticals? Absolutely not. We do need them.
yeah,
So I know that there's a lot of effort by the pharmaceutical industries to reduce the amount of waste that they produce.
yeah,
There's, for example, the American Chemical Society has a pharmaceutical roundtable in place.
yeah.
I think that's through the Green Chemistry Institute there. And
Wow.
so there's a lot of activity, especially on the waste side of things.
Yeah,
But the carbon footprint, I think, is on the minds of many companies, right? And so the idea of where do I get my power as like a really easy
yeah,
to think about in terms of carbon footprint is certainly there too. So I think they're on a good path. Um, I can't speak for all of them, but
Yeah.
it's good to see that move because it is because we can't do without these pharmaceuticals, right?
Absolutely. Yeah. And I know you talk about, the waste that's produced as a result of these medicines, right? And is there a way for us to maybe use that waste and reintegrate it back into society in a more positive manner? Like, have you seen any examples of that where this cancer-causing waste has now manifested into some other completely different product, but now it's in a completely different form, doesn't have as bad of an effect?
Yeah. So I mean, you're talking about the circular economy
Yeah. Yeah.
that we all would like to achieve,
Yeah.
right? And so then the question is, well, I mean, look around you in the environment, very little things are waste, everything gets utilized. So the idea of waste is a human
Yeah.
idea. So getting over that and thinking about how can we utilize some waste is important. Now there's this waste and there's that waste. When you think about these solvents that are often one of the big waste categories in pharmaceuticals, one way to reuse those, maybe not necessarily convert, but to reuse would be to find a clever way to purify them and be able to use them again.
I see.
Now, purification often is very energy intensive.
Yeah.
And so now you have to be careful, right? Do you use a lot of, energy and possibly increase the carbon footprint to recycle? The answer is that's probably a good idea, but you still need to be mindful about. So this is what we, call systems thinking, right? You need to think about all these different
Yeah.
aspects that can occur along the path.
Yeah.
Another example is there are examples of when I was talking about these individual reactions and there's waste being produced,
Yeah.
you can design the reaction such that the byproduct that you don't want can be something that's useful elsewhere. Now
Wow.
that's really cool, right? Now it's not just a byproduct, it's just a
Yeah.
second product you're making you can use somewhere else.
Yeah.
That though takes design of how do you make that reaction such that you actually get these two
Yeah.
products.
Absolutely.
So there are some examples of that, but that's often it's hard enough to get that first reaction to work the
Yeah.
way
Yeah. Yeah.
now you're adding something on top, right? So
Gonna
that's
make
why
it more challenging for
so
sure.
wrong. Yeah.
Yeah. And I know on that note of circularity, I think one sort of idea I've seen become more common is I see these companies creating this biodegradable pellet. And then this biodegradable pellet has the potential to not sort of be dispersed as microplastics in aquatic ecosystems, but then they're using that same sort of pellet to work in the fashion industry and to solve the problem of fast fashion so that rather than you having that piece of clothing maybe taken to a landfill, right, where it produces harmful toxins into the atmosphere, it's able to like biodegrade successfully. And so, can you maybe talk about this concept of being biodegradable? Is it something that's easy to achieve? Like, how does it sort of work? It seems magical in its thinking, right? Like biodegradable, it just magically sort of disappears, if you will. But can you maybe talk about how do we sort of achieve that goal?
Yeah, I could talk for hours about biodegradability, but why don't we start with the thought experiment? I mean, you go in I don't know, in the forest and you see leaves. We would probably agree they're biodegradable.
Yeah,
Probably not but not by the next spring.
yeah, yeah,
So the time frame is a good question, right?
yeah,
What is an okay time frame? Is it a day? Is it a month? Is it a year?
yeah,
Is it 100 years? Is it 1,000 years? So certainly it's not 100 or 1,000 because then we're going into the forever chemical problem, right? So
yeah,
you have to think about the time frames.
absolutely.
Um, the other thing about biodegradability, I know there's quite a few products out there that claim to be biodegradable, that are biodegradable.
Yeah,
So I don't know, think about these PLA cups. You see these clear cups for drinks or
yeah.
really for cold drinks. They're biodegradable, but under one condition. It
Well,
has to be really hot and it has to be in an industrial fermenter. So if
well,
you throw them in your yard, they'll cause the same problem.
yeah,
But if you put them in the right place, they're really biodegradable.
wow.
So that's unfortunate because now you're putting this on the user. The
Yeah,
user does.
never
The
want
user
to.
is
Yeah,
supposed to use this to know this, right?
yeah,
But if you live in a place where there is no industrial fermenter, well, then you can use them, but they end up as regular trash too. Now, is it an argument against PLA cups? No, it's not.
Yeah.
But it's understanding what are the limitations.
Yeah.
So let me say one more thing about biodegradability. So I wish I had a little presentation for you because there's a great story, and this is out of Germany in the 1950s.
Yeah.
Washing machines just came into play, and these companies were making the detergent.
Yeah. Yeah.
And it said, the best thing we can do is to make it really stable. Because if we make it stable, it can stay on the shelves for 5 years, and we can still sell it. Great idea.
Yeah.
Start using this detergent, and what happens? There's images. I think it's the River Rhine, where the river is foaming.
Oh my God.
Why
Wow.
is the river foaming? Because that detergent was so amazingly stable. So
Yeah.
after it had done a job being detergent,
Yeah.
it stuck around and it was making the river foam. Nobody wants to see a foaming river.
Yeah.
All right. So what do? Well, you have to actually make that detergent be as stable as it is, as it needs to be
Yeah.
for doing, the laundry.
Yeah.
But then when it's done with its useful life, because doing the laundry is its useful life, it needs to disappear so that the rivers don't foam.
Absolutely.
Turns out chemically that actually wasn't that hard. There were a few tweaks to the chemical structure,
Sure.
make it less branched,
Yeah.
and it worked beautifully as a detergent. And in the rivers, it was able to relatively quickly be degraded.
Yeah.
Biodegradation, the sunlight sometimes does some too. And so this is the ideal. You make a product that's stable in its useful life,
Yeah.
and that's as unstable as possible at its end of life.
Wow.
That
Yeah.
would be the goal. It's not easy, but it's doable.
Yeah, no, I think that's a amazing insight because for one, I think as a lot of consumers do is they see maybe these claims on the back of a plastic bottle that this is biodegradable and we sort of take it as face value. Oh, we throw it into the nearby trash bin, it's going to end up in the right place, right? But I think that's the sense of naivety on the consumer that these corporations are preying on. And
But that would be the goal, right? That
yeah,
would be the real situation that you could actually throw it, and that whoever's sorting sorts it into the right
to the
place.
right place. Absolutely.
Because otherwise, you'd have to have basically an instruction for every for every
Yeah.
material. And
And
who
the
likes
chances of, yeah, execution is so low. Yeah, like you say. No, so I think that's a phenomenal sort of story. Maybe we can sort of transition to tobacco industry and its effect on green engineering. I know that's a field of interest for you, right? And so I know one common consensus, right, when it comes to tobacco, unhealthy, right? Whether it be e-cigarettes, whether it be normal cigarettes, right, has a detrimental impact on human health. But sort of two questions I wanted to follow up on. First is the way that e-cigarettes are designed in just their structure, is it hard for them to potentially become biodegradable? Because I know a lot of the times the design of an e-cigarette is very hard to be recycled in any shape or form. And second question is a lot of the times I think we see these e-cigarette tobacco corporations preying on teenagers. And I know I was reading one of your posts where you talked about how they had to go from BPA to BPS in order to bypass legislation, but in reality, they're not changing much, right? At the end of the day, they're still preying upon teenagers to fall victim to these harmful chemicals. So how can we design an e-cigarette that can be disposed more easily, and how can we possibly enforce more strong regulation?
so many questions, right?
Yeah.
um, yeah, where to start? I would start with a plea, and I would say, if you want to vape, and I discourage it, but the idea that you take a disposable device
Yeah.
that has a battery
Yeah.
and you use it for 3 days, and then you throw it away, including the battery, is crazy to me.
Yeah.
Especially in 2025, where we're talking about sustainability so much, right? We're aware of the problem.
Yeah.
We know that the materials that go into a battery are valuable.
Yeah.
So, if it needs to happen, I think an idea of where you recharge a battery and you refill some part of the device with a liquid is, I mean, most certainly the better way.
Yeah.
Now, I don't want to get too much into the weeds of the e-cigarette debate. There are people that that suggests that there's fewer harmful compounds that come out of an e-cigarette than the cigarettes. And that's why we care, right? Sustainability is not only caring about the environment, it's also caring about, safety to people.
Absolutely.
And so, and that's strictly true if you look at, I think, 12 or 13 cancer-causing chemicals. There's less of them in an e-cigarette than in a cigarette. Problem is, e-cigarettes have compounds that are not commonly present in cigarettes.
Wow.
It took us 20, 30 years to figure out what these compounds in cigarettes do.
Yeah.
We don't really know the impact of those in e-cigarettes. And I'm speaking about the flavors, I'm speaking about other
Yeah,
additives that do all kinds of things.
for sure.
So, do I think that somebody who's a heavy smoker maybe should switch to an e-cigarette? There's probably benefits.
Yeah.
Does that flavor need to be, my favorite one is something like unicorn milk? Probably not, right? You were
Yeah.
smoking a tobacco flavored cigarette before.
Yeah. It still has that
So right. And I think the flavor is the transition to the youth use, right?
Yeah.
Now, are there companies that are catering to youth? Yes. Are there some that at least are saying they're not? Yes. So now we're back to legislation, right? Do we want to
Yeah.
regulate? So I can tell you the Netherlands, the country of the Netherlands, just disallowed all e-cigarettes that are not tobacco flavored.
Wow.
Right? They made that same argument I just made. They said, well,
Yeah.
if you're a smoker, you use a tobacco flavor.
Yeah.
E-cigarettes use a tobacco flavor. And then, of course, you have to think a little bit about this because what's a tobacco flavor? If you use
Yeah.
it, it's obvious.
Yeah.
It's tobacco flavor.
Yeah.
But in an e-cigarette, you always have to create it. So, can you add a little sweetness to the tobacco? Yes. So you want to limit the amount of sweetness, for example, that you can add
Wow.
to a tobacco flavor. And so I think the idea of designing a biodegradable e-cigarette may be one step too far, but the idea of, if that were to be a solution, how can you make that with as little impact on the environment as possible is a good consideration.
Yeah, absolutely. And I
Yeah.
think, on that note, right, achieving biodegradability, it is hard, right? But if we can sort of make the right steps towards getting near there or getting close to there, right? That's where we want to be. And I guess, sort of a follow-up question is, I know you had been talking about how companies will frequently just switch the type of chemical that they use, right? How can maybe users or people who are a part of that vaping industry, how can they be aware of that? And do you think it comes down to this matter of education where they don't know it or they do know it and it's just become an addiction? So
It's a hard one. So this one, started with menthol being banned in some
yeah,
states in the US. Menthol, most of your viewers know this. It smells minty.
yeah,
If you cold, it's the stuff you can rub on your skin, and it
yeah,
feels a little cold. You're not actually cold, but it feels cold.
yeah.
And so there's been work done in the I think 60s and 70s to find compounds that have this cooling effect, but they don't actually smell.
Yeah, wow.
Problem is, this cooling effect makes it easier to inhale. It's not a great feeling to inhale nicotine. It doesn't taste very good.
Yeah,
So if you can make it feel colder, it usually is less intense. And so there in these places, California, Massachusetts, where menthol was banned, these cooling agents appeared. In
wow.
cigarettes, they're also in e-cigarettes, and they just make it feel cool.
Yeah,
Cool as in cooling,
yeah,
right? And so that was one way to get around this legislation. And then in this commentary that you alluded to, we draw the bigger line to how the same works for the chemical industry.
yeah,
So BPA, bisphenol A, is a huge concern in some polyester or polycarbonates. I'm sorry,
yeah,
polycarbonates,
yeah,
and it's believed to be an endocrine disruptor. It acts as a hormone. It messes up, the body's function. So it's really not a good compound to have around. So what happened is didn't want to have BPA. So
yeah,
quickly, alternatives were found that were called BPS, BPF.
yeah,
Looked structurally very similar to BPA, But if you put that in, you could say, well, I don't have a BPA product.
Wow.
Fortunately, the problem was these, because they were so similar, they had similar effects.
Yeah.
So now you've done what we call a regrettable substitution. You've substituted a bad thing with another bad thing, and that's pretty regrettable.
Yeah. Yeah.
And so, and maybe to just wrap this up, sorry, the idea that we put forward there is to say, well, how does regulation in this country and in most of the world work? Is we say, okay, we know BPS is bad, we're going to say this is no longer allowed,
Yeah.
and then you don't have to, but you can get to this regrettable substitution.
So,
If instead we said, well, we're not banning this one molecule,
yeah.
but we're going to ban molecules that have the same properties than BPA.
Wow.
Now, what's a property? It can be that it causes this hormonal disruption. That's hard to prove, but we know what specific properties of the molecule can lead to that. So instead of banning the molecule, we ban the properties that cause
Yeah.
the problem. We avoid the regrettable substitution.
Yeah.
So that would be like one idea. That's not an easy one to implement. We've done regulation of chemicals like this for, you know, maybe not 100, but a long time, years. Um, but that was one idea that we put out there, and
Yeah.
could be interesting.
But I think when you say it, right, I think that in many ways is one of the beauties of chemistry as well, is you're able to sort of make structures that are so similar, different in name, but you change one small thing and you get this completely quote unquote new structure, right? I mean, that
Yeah,
sense of manipulation as a chemist is probably fun, but you also have to know when do you have to dial it back and think about the people who is impacting, right?
in
Uh,
fact, ideally always consider this, right?
Exactly. Yeah. So I think that's something you always have to have in the back of your head. And I know one sort of term you mentioned is polyester. And I know that today the entire clothing or a lot of the clothing industry uses polyester as a staple to create, t-shirts, blouses, dresses, whatever it may be. And so in your experience, have you seen a cost-effective replacement, to polyester? I know maybe silk, maybe potentially, but that is much more expensive, right? And who's going to be able to afford that, right? So have you been able to see it? And do you think we will see one sometime in the future?
Well, if I had seen one, you had seen one too,
Yeah.
right? Because it would
Yeah.
probably have been on the market. Um, so unfortunately, not really.
Yeah.
Um, Of course, there's cotton,
Yeah.
right? Cotton is a big one, but the cotton industry comes with all kinds of issues. So I think textiles, and there's a more and more drive towards thinking more about textile,
Yeah.
because there are so many aspects, right? It's about how do you grow the cotton, who does the picking, how do the coloring processes work, what are the byproducts there, what are the conditions in factories where clothing is being produced. So there's so many things that are in that field.
Yeah.
When it comes to the question of plastics, I'm just going to call them plastics. I guess I should be calling them polymers,
Yeah.
like a polyester. There are many ideas and approaches. Often they'll be based on some kind of natural material,
Yeah.
which is a great idea. And if you think about it, cotton is a natural material too. So those are valuable. Is it going to be enough? It's hard to say, right? Because the last thing you want to produce is monocultures to produce
Yeah.
some,
The same of it. Yeah.
yeah, and remove some kind of forest to
Yeah.
grow palm oil. That's the story we've had 20 years ago, 10 years
Yeah.
ago. So um, there may well be a need for polymeric textiles as well. And so then the question is, what do you make these out of? How do we make the polymers? Ideally, we don't make them out of petroleum,
Yeah.
because we know that the carbon and the petroleum that used to be in the soil then eventually ends up in the atmosphere. That causes the problems that we know, CO2, global warming. And so can we make polymers from renewable resources? Can we turn renewable resources into polymers? That would be a really interesting topic. And can you possibly make polyesters out of renewable resources? I'm pretty sure that yes.
Yeah.
Can we get to a society where we value reuse and recycling much more? I think yes, right? I
Yeah.
mean,
Yeah.
I'm you're not old enough. I'm certainly not old enough either. But there used to be times when people, had much less clothing. They would spend a lot more on them, but with the knowledge that they would last for a long time. And when they didn't fit you anymore, maybe your brother could wear
Yeah.
them. That's not a really nice thing for the brother, but it
Yeah.
worked pretty well.
Yeah. Absolutely. And I
So
think
it's an unsatisfying answer. I'm sorry.
no, 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 no. I think a lot of these questions, right? I mean, there's no sort of one easy solution to approach them, right? So I think that is so true when it comes to polyesters, and maybe sort of a tangential, topic is when you look at how plastics are made today, right? The amount of fossil fuels, non-renewable energy that goes into creating mass producing plastics, distributing out to consumers, right? That's something that maybe a lot of people aren't aware of, but I think recently the US is now going to go back to focusing more on plastic and move away from past measures that were implemented. And so do you sort of I guess this also goes back to regulation, but I mean, do you think plastic can be eliminated, well, when it comes to what we produce, what ends up, in the supermarket, right? These plastic water bottles, plastic containers, right? Do you think there is maybe an alternative we can find? Because I know there was a long period of time, and I know the Netherlands, Amsterdam is especially good in this, where they're able to find these sort of alternatives to plastic, and then people, I guess, listen in those sorts of cities. So do you think we're able to do that maybe here in the United States as well?
Yeah, the question of plastics is such a big one, right? I mean, I have to keep in mind there's a reason we're using it.
Yeah,
It is so convenient. It
yeah,
does so many things that we want, right? I mean, talking about trade-offs and systems think about if you were to use glass for all the containers we use now in plastic.
yeah,
It would be heavier. You would need more, energy to transport and to make them. So there are benefits to plastics, right? We have to recognize that. At the same time, you've just outlined a lot of the problems of plastics. So in an ideal world, I would say, let's keep the plastic, let's keep the functionality of the plastics, but let's get rid of the other stuff.
yeah,
Well, that's not going to happen in the next 5 years,
yeah,
probably, right? So that's a longer term project, and encourage everyone to get involved because it is such a big topic. Um, and so then we can also come back to the question, whose responsibility should it be, right? I mean, yeah, okay, can we expect that somebody at home can separate plastic from other waste? Maybe we can expect that, and maybe that's fine.
yeah,
But at the end of the day, we can't put it all on the consumer because, as we said earlier, you may not know and you may do it wrong, and that's okay. Like nobody's judged because you didn't read the label that's hard to read in the first place, right?
yeah,
Right? Or you didn't rinse the plastic. I mean, there's so many like things to this.
absolutely.
So there has to be also some responsibility by, is it the manufacturers that need to figure out how to take back the material and possibly be able to recycle or even just reuse it?
Yeah,
Absolutely, yes.
yeah,
But it's a tough one because of this. We're used to it. The functionality is great. So I guess the other thing I'll say about plastics is a lot of plastics polymers, when you make them into the materials that they're going to be used in, there's all kinds of additives to them. So you rarely just get polyester or polyvinyl chloride,
yeah,
but you need all these additives to be able to process or color or get the properties you want.
yeah,
And so, let's say we achieve this great circular economy where we can reuse, recycle a lot of the plastic. That would be amazing, right? We would have to be really careful about those additives because
yeah,
if the additives are problematic, and I'll give you an example,
yeah,
plasticizers in polyvinyl chlorides, called, a lot of them that are used are called phthalates. They're thought to be acting like hormones. Hello, BPA,
yeah,
right? So do we want those to circulate? Probably not. So what we need to do is we need to design the plastics of the future so that they can actually be more easily be reused and recycled, and we avoid problematic compounds in them in the first place.
Absolutely. No, I think that issue is never easy, especially because the topic of plastics, right? You look at it, its effect on, aquatic ecosystems. Recently, I read an article about microplastics actually being present in the brain in itself, which when I saw that, I was fascinated by it. But, thank you so much for sharing all your wisdom, all your insights into all these topics. And just one last fun question I like to end off with is what would you sort of say to someone who's just entering the field of environmental science and they don't know what to do, what maybe other field to intersect it with, like you did? And so, what advice do you have? Like, where should they go and how do they get involved so someday they're able to make the level of impact that you've been able to do?
Yeah, I would say there's two things I would recommend.
Yeah,
One is to, be open-eyed, look around, see who you can listen to. I mean, nowadays it's actually really easy to listen to people, right? And then, it may be finding somebody who's able to mentor you, right? Somebody who's a good mentor is always really helpful, right? Somebody who's just inspiring. Um, so I think that's a really good thing. And then I think the other recommendation is to try to think outside the box. Now,
yeah,
that's a phrase that everybody's heard before, but it is true. So I don't know. I learned to be a chemist. Other people, you said it earlier, study math or study other things.
yeah,
But think about the concepts you've learned and see if you could apply those elsewhere, where somebody may say, well, that's not chemistry, but that doesn't mean that a concept in chemistry may not be applied elsewhere, right?
yeah.
So it's sort of being open-minded and like being aware of the knowledge you have and where it may be useful elsewhere.
Yeah.
Sounds abstract, but is good practice.
Yeah, no, I couldn't agree more, especially because if you are able to tie it with the environment, with climate innovation in any sort of way, right? Then you're taking a field and you're finding a way to create some sort of social societal good, which is always what you want to do, with the work that you're doing. So,
Great point. The,
yeah,
the the societal aspect comes into that too, right? It's not only a science answer, but society needs to too.
yeah, awesome. Thank you so much, Hannah, for taking the time to be on our podcast early morning. Thank you so much to all our viewers as well. And we'll see you all on the next episode of Earth Day Every Day. Thank you so much.
Great. Nice to meet you.